I believe we can start. Good afternoon, everybody. Welcome to session 6A. I'm Kıvanç Kaglar. I'm managing WSP's Traffic Engineering Group in Philadelphia office. Today I'll be moderating this session, which is about repurposing roadways, also referred as road diet. We have 3 interesting presentations and 4 excellent speakers. Our first speaker is Keith Johnson from Gannett Fleming. Keith has over 33 years of experience in private and public sector with transportation planning, design, and engineering. Currently, he is serving as the project manager of the Design Manual 2 Rewrite project. Keith will give us an update about the chapter on road diet proposed to be included in the latest version of Design Manual 2. Our next speaker will be Rick Mishura, lead traffic engineer with WSP and a graduate of Penn State. Rick has more than 25 years of experience in transportation engineering projects, including planning, modeling, design, and safety, serving clients in Pennsylvania, Delaware, New Jersey, and New York. Rick will tell us about the SOUCI reconstruction project in PennDOT District 4 that he's been serving as the lead traffic engineer. Our last presentation will be focused on Washington Avenue improvements in Philadelphia. Lily Reynolds and John Federico are the 2 co-presenters. Lily is currently serving as the Deputy Director of Complete Streets in City of Philadelphia's Office of Transportation, Infrastructure, and Sustainability. She is an urban planner specializing in complete streets, community engagement, and transportation capital project management. She brings 5 years of experience in city planning in the United States and over 10 years of a community engagement experience in Canada and Spain. John Federico is a supervising transportation planner with WSP with over 21 years of experience, serving as the project manager of the Washington Avenue Improvement Project. He's a certified planner and a professional engineer, delivering multimodal transportation planning and design projects with a focus on promoting active transportation. Our session today is being recorded and can be viewed later as needed. I hope that we'll have a few minutes left at the end of our session to answer some of your questions. Please feel free to reach out to our presenters with your individual questions in case we run out of time. With that, I will pass the stage to Keith to get us started. Thank you.
Okay, thank you. Karen, is my screen being shown okay, and is my sound okay?
Yes, we can see it.
Yes, it is.
Okay, great, thank you. Good afternoon, everyone. My name is Keith Johnson. I'm a senior project manager for Gannett Fleming. What we're going to go over today is Design Manual 2 Rewrite, and with that, we're going to have a proposed new chapter on road diet. My general agenda here for my presentation is, first I want to give you an idea of what the DM2 Rewrite is all about, and then I'll go over the aspects of the proposed new chapter with the road diet. And I'll just forewarn anybody who's in the contextual section that we had yesterday with Brian Shunk. This first part is going to be a slight regurgitation of what I went over yesterday, so if you want to hurry up and go get a drink for a couple minutes, my feelings won't be hurt here. So first of all, what is the DM2 Rewrite? First of all, again, most of you are probably working in Pennsylvania and know what the DM2 is all about. But for those of you that are from out of state and don't do much work in Pennsylvania, just to give you an idea, we have PennDOT has a manual. It is publication 13M, Design Manual Part 2. We call it the DM2. This is the main design manual, highway design manual. It's probably the most used design manual of PennDOT's publications. What we are doing is we're doing a complete rewrite of the publication, not just an update, a rewrite of it. And as we do that, we will be putting that in what's called publication 13. Talked a little bit about this yesterday, I'm sorry. 13M was created by PennDOT a few years ago, back when we were talking about converting over to metric, and that's where the M came from. So we had publication 13, and then we have publication 13M that has metric units in it. We didn't do that conversion, but we left the whole design manual in 13M, but we still theoretically have a publication 13. So we're going to just be putting the new chapters in there as we publish them. So as we approve the new chapters, there's about 24 of them. Once we get approval, we'll be sliding those into Pub 13. And then in Pub 13M, we'll be putting a little note on that to refer people to Pub 13 for whatever chapter we're talking about. So changes in the rewrite. Like I said, this is going to be a complete rewrite, just not an update. Couple things with all that. A couple of the major things we're going to be doing. We're trying to make the design manual more user-friendly, easier to read. So with that, we're adding a lot of graphics, photos, call-out boxes for information. Every chapter is going to have a reference section right in front. So as you're working on a particular topic, we're giving you different references outside of PennDOT that you can look at to help you with your design. Where needed, we're putting example calculations in. The aspect is we're not regurgitating what's in the AASHTO Green Book. We will refer to it, but we're not necessarily duplicating the AASHTO Green Book unless there's something really important we want to show. And then as far as a lot of you, if you work in the DM2 right now, you know, you might be looking at a certain topic and then you go to the Green Book and it's in a completely different chapter in a different section. We're trying to follow the flow of the AASHTO Green Book, so it's easy to go back and forth as you're doing your design. In general, the philosophy of the design book is we're trying to add more flexibility for design. So when we need to give a hard, fast number, we'll give a hard, fast number, but we also are leaving things somewhat open so we can apply some engineering judgment to our design. And we're incorporating complete street concepts and context sensitivity into we're doing. And again, lastly, we're trying to gear this for what we're calling the new designer. You know, we are going to have a lot of people retiring in our industry. We're going to have younger designers coming aboard, and we want to make sure we give them enough information so the design manual is helpful for them as they're doing their design. This is the general layout of the new DM2 as we put this together. We have a total of 25 sections, 24 chapters. We have these in different type of sections. So we have a design guidance section right at the beginning, sort of telling the philosophy with context-based design and showing our design controls. Project type specific. So we're breaking out our, you know, basically our types of projects. So we're going to have a new construction and reconstruction section, and then pulling out 3R and pavement preservation. A lot of times people are a little confused on what the difference is between reconstruction and 3R. And we're going to have a bridge project chapter. We don't have a bridge project chapter now. That doesn't mean we're designing bridges in here. It's more the highway component of designing bridges. Next, we have design details, different aspects there, which we'll go over in a second. And then modal considerations. We're adding some new chapters dealing with the different types of non-auto modes out there. And then we have our additional topics section. As far as the new chapters go, these are all the new chapters here. Like I said, we're breaking out 3R and bridge, the road diet, which I'll get into in a minute. We're going to have an MPT chapter. And then again, we've added, right now the DM2 has nothing, maybe a paragraph or two on some of these topics. Transit freight. For those of you that aren't sure, Plain People Community, that's our chapter dealing with the Amish community and designing for horse and buggies, that sort of thing, and then a couple other new chapters. And sorry, my phone's going on. As I mentioned, what we're doing with the chapters is we're going to have right up front in the chapters, we're going to have a reference and resource section. This is what is in our road diet chapter reference section. So there's different aspects. Some of these are dealing strictly with road diet. Some of these are dealing with bicycle facilities and how you want to work in these or walkable type of things. And then flexibility and design diagram. This last one here that I highlighted, this is the main document we use to develop our road diet chapter. This is the road diet information guide from Federal Highway. It's a good resource. And like I said, we modeled the chapter after what was in that document. So what is a road diet? Everyone has a different definition of what a road diet is about. Road diet is generally described as removing travel lanes from a roadway or reducing travel lane widths and utilizing the space for other uses such as. This is our definition in our chapter. So if we're reducing lanes, you might be reducing lanes to provide space for parking, pedestrian facility like sidewalk or bicycle facilities. And then most road diets are usually utilizing a center two-way left turn lane. And obviously we all see that acronym a lot. By the way, I forgot to mention this as we're going along. Like I said, we're probably going to take questions at the end, but as I'm presenting some stuff, if you have any questions, feel free to throw it in the Q&A or the chat and we will get to it. For the most part, when I'm presenting, it's a little hard to look at that as we're going along, but feel free to type things in as we go along. This is a typical example. There's different configurations. This is a 4-lane to a 3-lane road diet. So the concept here is we're taking the inner lanes, we're creating a 2-way left turn, and we might be reducing the lane width to, again, might be providing parking or a bike lane or for sidewalk or something like that. Next configuration is a 4-lane to 5-lane. Again, same sort of concept here. In this case, we're keeping we might be keeping the curb to curb width exactly the same, and we might be narrowing the lanes to fit the 2-way in. The next configuration, a 2-lane to 3-lane. Again, same sort of concept, but with a 2-lane road. 2 other configurations, possible configurations, is you're staying with a 3-lane, but the idea is you're narrowing the lanes because, again, you want to do something on the side. Might be parking, might be sidewalk, might be bike lane, something of that nature. And then lastly, we have a 5-lane to 3-lane concept, again, with the idea of reducing the lane width because we want to be doing some things on the side. So key context questions, and again, in the DM2 update, we always have a section called context questions. So these are questions we just want the designer to think about as he's looking at his design. So for the road diet, first question, how will road diet impact mobility, safety, and access for the road users? A typical question here when we're thinking about 2-way left turn lanes. So if you have a 4-lane road, is the roadway functioning as what we call a de facto 3-lane road, where what we're talking about is the inner lanes are more or less acting as left turn lanes. And because you have so much of that left turn traffic happening, especially in the peak hour, the existing 4-lane, it causes the through traffic to just use the outside lane. So is that happening out there? You want to get a good idea of whether that's occurring or not. Vehicle speeds greater than the context supports. One thing with, if you're narrowing the lanes, it's shown that will reduce speeds. Sometimes we think if we just lower the speed limit, people will slow down. That basically isn't the case, but this is a good way of reducing speeds if it makes sense in the corridor. Next, public perception of the corridor. We highlighted this, and this even came up when we were doing it. Usually we don't mention public involvement in the specific design manual, but you definitely want to have a public function when you're doing road dies, because it can look somewhat radical to the public, and you want to make sure they understand what's going on there. And then looking at different components here, I'll get into. So our key design components that we're flagging: site distance, access management, how the driveways and offsets work. And again, we want to include bicycle and pedestrians. Site distance is sometimes overlooked. You are changing the horizontal site distance of the roadway, so you want to make sure you're looking at things like that. As far as intersections, well, first let me hit design vehicles. We are talking about maybe reducing lane widths, so you want to get a good handle on what your design vehicle should be for this. If you have truck traffic is somewhat light or not a lot of transit usage, going from a 12 to 11 or a 10 can be doable. If you have transit, you want to watch that. Usually we don't like lanes to be less than 11 feet for transit vehicles. Their overall width with their rear view mirrors is about 10.5 feet. So if it's a major transit, you want to keep things like that in mind. Design elements. This is an example of, if you have intersection offsets, you want to pay attention to that. Obviously, you would rather have this sort of situation as opposed to this sort of situation where you could actually create conflicts with people coming in. So trying to flag those type of elements in your road diet. Obviously, we're looking at improved safety with this, especially if you have a lot of left turn lanes happening here. Again, these diagrams, wherever you see the little white spot, those are conflict points. So the idea, if you have a lot of left turns happening here, putting the two-way left turn lane reduces the conflicts. And then if you have an unsignalized intersection, same sort of thing there. Operational considerations, again, if you have a de facto situation happening here from a 3-lane or a 5-lane perspective, you want to definitely look at that. Depending on how much traffic you have on here, you could have a level of service issue. So want to pay attention to level of service and ADTs. And then, as we talked about, especially with two-way left turns, you really want to get a handle on how much turning volume you have out there and what's going on with that. Now, with that, with the chapter, we don't have a lot of strict numbers to say, if you have this, do that, or anything like that, because really, and you'll see with the example projects we're going to go over, every road die project is very unique. So you really want to watch just looking at a straight number. We do have this guideline, basically Federal Highway throwing out there. If you're around 15,000 or less, you probably have a good candidate for 4 to 3. That doesn't mean if you have 20,000, don't look at it or anything, but that's usually an indicator. Threw this out. This is not in our chapter, but it is from our informational guide. This is an interesting thing Seattle did for determining capacity. Again, this is just for a 4-lane to a 3-lane. And their general rule is, if you have over 25,000, it's just not going to cut it. If you have less than 10, you probably have no problem whatsoever. And then the rest of this, they were kind of laying out how to look at this either from a corridor analysis or a key intersection analysis. So I thought this is a nice model of, if you're approaching this, you might want to adopt this type of methodology to look at capacity. And then lastly, I wanted to just throw out crash reduction factors. With this being said, just want to flag a couple things. Again, this isn't in the chapter, but want to give people an idea. These are crash reduction factors. If you're not familiar with it or haven't done it for a while, the CRF is, if this one's 44, that means you have a 44% reduction in crashes. So from the clearinghouse Federal Highway has, this is for 4-lane going to a 3-lane basically, and crash reduction factors. in the range of 37 to 44 in an urban condition. And this is for going from a 4-lane to a 5-lane situation. Again, some pretty promising crash reduction factors. These are some more. This is for a 4 to 5-lane conversion. And again, this is just giving different numbers. These are for urban non-intersection roadways, and these down here are for urban and suburban. So some nice numbers as far as crash reduction goes. I did want to flag, so some of this we're talking about reducing lane widths. And I don't want everyone to get an idea this is just a panacea of doing this sort of thing. If you're looking just at lane width reductions, you're getting negative CRF values. So these here are for rural situations from the clearinghouse, and these down here are for suburban and urban situations. So you're getting negative, so that's not that great. However, the whole idea is if you're introducing a two-way left turn lane, you can offset these with the increased safety you have with the two-way left turn lane. In my mind, I always put it in, it's analogous to you have a stop intersection and you go to a signalized. When you do that, when you put a signal in, you might increase rear end collisions, but you're greatly reducing head-ons and angle crashes. So overall, the severity of the crashes is a plus. So you can think of that in the same way with the road stuff. Button is stuck, sorry. There we go. Okay, and with that being said, as far as Brian Shunk is our project manager with the DM2 update, and here's our contact information, and these slides will be available. And with that being said, I ran a little over, apologize, I'm going to pass this right off to Rick.
Great. Can everybody hear me and see my screen?
You're good, Rick.
Great. Thank you. Hello and good afternoon, everyone. Glad to be here today to discuss the SOUCI reconstruction project. I'm Rick Mashura, lead traffic engineer working for WSP in their Philadelphia office. A brief history of the corridor. Original construction of the roadway was completed in the 1950s. As you can see from the opening picture, the roadway is in poor condition. A recent repaving project was completed in the fall of 2019. But PennDOT is looking for a long-term project to improve the parkway, which includes a potential lane reduction, road repurposing of a single lane in each direction with center turn lane along the corridor. We have specifically refrained from using the term road diet, as the public seems to have a negative connotation of this term. This project is located in Northeast Pennsylvania in Luzerne County, PennDOT District 4, just south of Wilkes-Barre. The project study area is outlined in green. The SOUCI Parkway is a 4.2 miles in length urban principal arterial and includes 6 signalized and 6 unsignalized intersections. The entire limits are within Hanover Township, Luzerne County. Nanticoke is to the west and the city of Wilkes-Barre is to the east. SOUCI Parkway connects with ID1, the blue highlight in the lower right portion of the graphic, via PA Route 29, the red highlight. The typology along the roadway differs from the corridor from commercial on the western portion to residential in the middle, and then a mixture of commercial, light industrial on the eastern portion. Of interest is a railroad crossing through the easternmost signalized intersection. Speed limit is predominantly 45 miles per hour within the study area and 35 miles per hour east and west of the study area. We are currently in preliminary design with an opening year of 2025 and a proposed design year of 2045. Additionally, the South Valley Parkway connection, which is highlighted in yellow, was completed in 2019. The project purpose is to determine the typical section of the roadway based on all modes of transportation through PennDOT Connects. The picture on this slide depicts typical travel modes along the corridor, which includes no traffic congestion, few pedestrian amenities, and inadequate facilities for bicyclists. Due to the wideness of the roadway, speeding is an issue along the corridor, as 75 to 80 speeding citations per month are issued by the Hanover Township Police Department. Of note is the person pushing a baby stroller in the roadway due to an absence of sidewalks. Census tracts were reviewed in the area, which show that 13% of the population do not have access to a vehicle. This identifies a need to accommodate all modes of transportation. To begin to understand the corridor, the next few slides will showcase existing conditions, including volumes, crashes, and access management. These are the typical cross sections found along the corridor. Predominantly a 4-lane section, 2 travel lanes in each direction, with turn lanes provided at select intersections. Shoulders vary from very minimal, about 1 feet wide, to 8 feet wide. Interestingly, the roadway transitions to a single travel lane in each direction, east and west of the study area in Wilkes-Barre and Nanticoke, respectively. Our civil design team is progressing with a 35-mile-per-hour design speed. Normally, high volumes and congestion create operational issues along a corridor. In this case, traffic volumes have decreased over time based on the data shown from 2005 to 2019. Population has decreased in Nanticoke and Wilkes-Barre, and the current 4-lane cross-section is underutilized. The latest ADT we collected in 2019, pre-COVID, showed a little over 12,000 vehicles per day. Based on the current ADT and FHWA criteria, the SOUCI Parkway is a good candidate for potential road repurposing. When developing future volumes, we contacted the Lackawanna Luzerne MPO for growth factors in the area. Unfortunately, none were available. PennDOT growth factors per county was referenced, which initially showed 0% for urban, non-interstate. Since we were proposing a lane reduction along the corridor, we used a conservative total growth of approximately 11% to the future design year of 2045. This growth accounts for additional potential developments south of our study area with the recent construction of the South Valley Parkway. Along the eastern section of the corridor, there is a high number of mid-block pedestrian crossings occurring between the light industrial warehousing land uses and subsequent parking lot and commercial properties on the other side of the roadway. The upper left photo shows its current crossing. Picture on the right illustrates that more than 400 pedestrian crossings are occurring here during a typical weekday. An additional concern was a pedestrian fatality that occurred here. A common theme along the SOUCI Parkway is the lack of access control, with in many cases no defined driveways. In this photo, for example, the color-coded parcels on the north side of the roadway have no designated driveways, as the entire frontage can be accessed from a driver. This, coupled without a center turn lane, causes vehicle conflicts. Access management was reviewed along the corridor, specifically for accordance to Pennsylvania Code Title 67, Chapter 441, which states that 1 driveway will be permitted for a residential property and not more than 2 driveways will be permitted for a non-residential property. If the property frontage exceeds 600 feet, the permit may authorize an additional driveway. New HOPs are expected as part of this project. The benefits of access management include improved movement of traffic, reduced crashes, and fewer vehicle conflicts. The latest 5 years of crash information was obtained, years 2013 through 2017, analyzed and plotted. 213 total crashes occurred during this time frame, and 5 fatalities, including an additional fatality in 2018. 3 of the fatalities included pedestrians. Not surprisingly, signalized intersections and horizontal curve alignment highlighted high crash locations. The intense red area in the upper right of the graphic highlights a section with high conflict of vehicles due to poor access management and conflicts with pedestrians and vehicles. When preparing our preliminary traffic report, these are a few of the traffic analysis performed, which we will further discuss today. 4 scenarios were analyzed. 4 peak hours were reviewed: weekday AM, midday, PM, and weekend Saturday. As Hanover Area Junior Senior High School is on the corridor, The midday peak was included, along with an extended PM peak hour to catch volumes during the school dismissal times. Synchro-sim traffic was utilized for all scenarios, and our metrics included intersection and arterial level service, travel time, and projected queues at the intersections. For sim traffic simulations, 10 runs for each scenario was averaged and provided in the results table. As illustrated earlier regarding the volumes, the corridor would operate successfully with the lane reduction as noted by the arterial level service and an increase in travel time of only about 20 seconds. No issues with intersection level service and queues are expected. This was one of the many travel time graphs illustrated in our preliminary report for all scenarios proposed. Of note is the dotted green future lane reduction scenario to the dotted blue line future no build scenario. The biggest increase of travel time with the road repurposing was approximately 20 seconds. An additional analysis performed was for truck climbing lanes. There is a crest of a vertical curve in the middle of the project area. When looking at an alternative to reduce the cross-section to a single lane in each direction, a truck climbing lane analysis was conducted for necessity. The eastbound section highlighted in blue has an average grade of 3.3%, while the westbound section highlighted in green has an average grade of 4.3%. Chapter 2 of the PennDOT design manual was utilized in the analysis and summarized in the next slides. 3 criteria is outlined in DM2 and should be satisfied to justify a climbing lane, which is summarized in this table. Criteria 1 is an upgrade of traffic flow rate more than 200 vehicles per hour. Criteria 2 is an upgrade truck flow rate more than 20 vehicles per hour. And for criteria 3, one of the following conditions must be met. A 10 mile per hour greater speed reduction is expected for a typical heavy truck. B, level of service E or F exists on the grade. And C, a reduction of 2 or more levels of service is experienced when moving from the approach segments to the grade. The first 2 warranting conditions consider the volumes of vehicles and trucks traveling the roadway. The number of vehicles and trucks must be sufficiently high to cause measurable delay due to crawling trucks. DM2 references the AASHTO Green Book for criteria 3A, which provides graphs for critical lengths of grade along curves, 10 mile per hour speed or greater lane reduction. HCS was utilized for criteria 3B and 3C. Per the analysis, a truck climbing lane is warranted and was incorporated into the design. A predictive safety analysis was then performed in order to determine the correct analytical method. FHWA's scale and scope of safety assessment methods in the project development process was referenced. Due to the significant geometric improvements planned for the corridor, the project is considered a project type 4R. Because of this designation, this led to the determination that our analysis should utilize an SPF with CMS adjustments. PennDOT Pub 638A, Pennsylvania Safety Predictive Analysis Methods Manual was followed. This graph depicts predicted crashes along the corridor segments based on 3 scenarios analyzed. The existing section, which is 4-lane with no center turn lane. A 3-lane section, which includes a center turn lane, and a 5-lane section, which also includes a center turn lane. Of note here are the results of the 5-lane section, which includes a center turn lane and high predicted crash results. This is due to higher expected multiple vehicle, non-driveway, and single vehicle crashes, and the likelihood of increased speeds due to the wider roadway. We acknowledge that the CMFs in Keith's earlier presentation show that restriping a specific 4-lane undivided roadway with the center turn lane generally leads to a reduction in crashes. But when examining all roads on a statewide level, PennDOT has found that a 5-lane roadway, including a center turning lane, has more crashes than a 4-lane undivided highway. Based on the safety comparison, the 3-lane section option, which includes a center turn lane, is predicted to be the safest cross section. The crash results were quantified and a benefit cost ratio for the 2 alternatives was provided. Cost per fatal and injury and property damage only crashes were summarized for each option in total for comparison. A benefit was calculated in comparison to the existing section, and then a benefit cost ratio was calculated based on the infrastructure cost. The 3-lane section construction cost was approximately $13 million less than the 5-section. This graphic was key in getting buy-in from the stakeholders and provided us with moving forward with the 3-lane section design. When it was time to get together for our stakeholder outreach in July of 2020 this year, it was impossible to have it in person due to the COVID-19 pandemic. The meeting occurred virtually with PennDOT, Hanover Township, and the legislators. Before delving into the alternative roll plots, this graphic was shown, which summarized all the existing traffic information for discussion. This included traffic volumes, crash cluster locations, structure information, and points of interest. Based on our stakeholder outreach, we are proceeding with the 3-lane section as the preferred alternative. As mentioned, we are currently progressing through preliminary design. One of the main things from a traffic perspective will be to conduct intersection control evaluations to help determine the best control option at each intersection. Since the preferred alternative is the 3-lane section, we'll be limited to 3 options on signalized, or roundabouts at intersections. The image shown here is a concept of a potential alternative with a rectangular rapid flashing beacon for the mid-block crossing at the eastern end of the project. Lastly, I'd like to thank PennDOT District 4, especially Robert Kretschmer and Robert Wasselcheck, and their entire traffic unit, Hanover Township, and our WSP team, including Kavanch Kaglar and Will Cowan in traffic, and our civil design team led by Tom Friel and Rich Ames. Thank you for attending this session. Now I will pass it over to John.
Hey, good afternoon, everyone. My name is Lily Reynolds. I am the Deputy Director of the Office of Complete Streets with the City of Philadelphia. Happy to be here today presenting with John Federico of WSP on our project on Washington Avenue. We're going to go through the project background, describe some of the roadway layout options, traffic modeling that was used to identify those options, and then the public process to determine the preferred layout. So for those not familiar, Washington Avenue in Philadelphia is a major east-west commercial corridor, and it's really running through sort of south of the South Philly neighborhoods, river to river. So you can see on this map here in blue, the corridor is highlighted and the project area is highlighted, and it really forms the southern end of the Center City area. It is quite a wide roadway, partly due to the history of having heavy rail down the center of Washington Avenue. Over time, land uses around the corridor have changed, going from industrial and light industrial to now predominantly commercial and increasingly residential and mixed use land uses. This project has been looked at for several years in different phases, and really we are relooking at this corridor because it is scheduled to be repaved next year in 2021 between Grays Ferry Avenue to the west and Delaware Avenue to the east. And this resurfacing project really gives the city the opportunity to do more than just repave the roadway and create a more safe and accessible corridor. This project evaluated, as I said, alternative roadway configuration concepts, and we conducted analysis with WSP, including impacts of traffic operations, to form the preferred concept. The project goals are really to create safer, shorter, and more consistent pedestrian crossings. You can see in the image on the top right, one of the intersections of Washington Avenue at 13th Street, and there's really a very long and exposed cross-section for pedestrians to manage. So this was definitely one of the project goals, as well as decrease weaving, speeding, and aggressive driving. These are some of the most consistent driver behaviors on the corridor that we also see in some of the crash data. We also wanted to keep cyclists safer by separating them from moving traffic. Today, as you can see in the bottom right-hand photo, there is a standard bike lane on the corridor. However, it is not only faded, but in part due to some of the inefficient parking and loading operations. Often that bike lane is inaccessible to cyclists. So as you can see, the cyclist has to weave out into moving vehicle lanes to keep going. So we wanted to address that, protect the cyclists, and also we wanted to sort of rationalize and improve the parking and loading operations while preserving space for trucks and buses, as there is a SEPTA bus route, the number 64 that goes along this corridor. Improving safety was really important for us. This is part of our Vision Zero portfolio of projects. So we looked actually at a longer time period than the standard 5-year crash window, because as I said, the city has been looking at this project as early as 2012. So here in some of our public materials, we wanted to represent the stories of those people who have been severely injured or killed. You can see with the red dots or the red stars, locations where there have been a fatality between 2012 and 2018. And with the blue stars is a crash with a major injury during that time period. The yellow indicates the project limits. And to the right, there is another project that we're coordinating with, led by the Delaware River Waterfront Corporation. John?
Okay, all right, thanks, Lily. As Lily mentioned, I'm John Federico. I was WSP's project manager for this. I'm gonna kind of quickly go through the layout options that we worked to develop with the city, as well as the following analysis. Before I do that, just wanna give a little more context on the corridor itself. Our project limits are just under 2.5 miles long. It includes 22 signalized intersections with each of the numbered side streets. We conducted traffic counts in April of 2019 and found that the average daily traffic was a little over 23,000 vehicles, and the posted speed limit is 30 miles an hour. And then you can see here the existing cross section, which includes 2 travel lanes in each direction, a 2-way center turn lane with left turn lanes at the signalized intersections, a conventional bike lane adjacent to a parking lane, and then sidewalks that are 8 to 12 feet wide. Okay, and then to address the project goals that Lily just reviewed, we developed 3 reconfiguration alternatives for the road. The first one, probably the most straightforward, is what Keith mentioned as a 5 to 3 lane road diet. And so what this would do is reconfigure the road to show the cross section in the bottom left, which would result in 1 travel lane in each direction. It would retain the center 2-way turn lane, but it would use that extra space to essentially flip the parking and bike lane and create a parking protected bike lane. And this would help to meet the project goals by dramatically reducing the effective distance that pedestrians have to cross between the parking lanes. It would provide that parking protected bike lane, eliminate those double parking conflicts. And then interestingly, would also in some parts of the corridor provide some space to widen the sidewalks where they're narrower. And in the short term, since this is a repaving project, that could be done with textured or painted surface as shown in the bottom right photo. But in the longer term, there's the potential to maybe widen them out with development or capital projects. Now, the next option is what we were calling a 4-lane cross section or an unbalanced section. This would have 1 lane away from Broad Street and 2 lanes in each direction towards Broad Street and retain the center turn lane. And the reason for doing that really has to do with increasing capacity, auto driving capacity in this option, and accommodating where there's the highest vehicle traffic flows. It would also provide enough room to create a parking protected bike lane, but it wouldn't have the space to provide those widened sidewalk areas. And so the benefits of this option are that it would help from a travel time and traffic modeling perspective, which I'll get into, but it doesn't help in terms of the pedestrian crossing and addressing some of the project goals related to safety, because you would still have that multi-lane section with the aggressive driving in one direction. And then the final option is what we were calling a mixed cross section, which is essentially just a hybrid of the other 2 options. And it applies the 3-lane section towards the edges of the corridor where the volumes are less, and then the 4-lane cross section closer to Broad Street. And it would have a mix of benefits depending on which section you're in. I want to definitely highlight that parking and loading analysis was critical and integral to all of these options. Currently, the lack of regulations, there's no regulations on parking and limited regulations on loading. And that combined with insufficient loading zones led to very low turnover throughout the corridor and frequent double parking, sidewalk parking, and median parking. So early on, we realized that addressing the double parking issue and the lack of turnover was going to be integral to making any of these options function and operate. So don't have a lot of time to get into it today, but we did do a parking and loading analysis, and we came up with improvements based on that analysis, which included strategically adding loading zones in front of businesses where they're most needed, as well as adding regulations, time parking, and some new loading regulations to the corridor. We worked with the cities to develop and the businesses to develop block by block plans for those improvements. Okay, so now I want to get into the traffic modeling. The key next step was modeling these options to address questions from the city, public, and stakeholders. And this was particularly important since the ADT was at that higher threshold of a road diet application. So we needed to do a lot of detailed analysis to see how this corridor would function under each of those options. And an important part of that analysis was understanding and thinking about diversion and the potential for diversion, since we're in a network in an urban environment. There are a couple key questions to that. Well, the first is, are motorists using Washington Avenue to access Center City and bypass congestion on the regional highways? So we used streetlight data to conduct an origins and destination analysis and look at what percentage of vehicles are entering Washington Avenue from the regional highways and perhaps using Washington Avenue as an alternative cut through or diversion route to Center City. So you can see here just one example using I-76. We found that relatively low number of commuters were using Washington Avenue to access Center City, which is shown in blue there. It was about 30 vehicles in the AM. And extrapolating that and conducting that analysis on the other highways, we found the same. So our conclusion here was that there was kind of limited potential for it being used as a diversion route or for diversion from Washington Avenue back to the highways. And the second question is trying to get an understanding of once vehicles enter Washington Avenue, do they travel the length of the corridor? Are they using it as a crosstown route? Or are they really using it for shorter trips and turning off at specific locations? And using streetlight data's top route function, you can see the line in pink there shows eastbound traffic. Heading eastbound from Grace Ferry Avenue, by Broad Street, about 50% of the volume had dropped off. And by Columbus Boulevard, we were down to less than 10% of the volume. And in the westbound direction, it was even more pronounced, where 50% of the volume had dropped off by 5th Street, and we're under 10% through the corridor. So this showed that less than 10 to 5% of the vehicles, or 5% of the vehicles, were using Washington Avenue to travel the whole length. And really, it's used a lot more by local vehicles for shorter trips to access businesses and destinations along Washington Avenue. So based on the OD analysis, combined with some research we did on similar road diet applications across the country in other urban contexts, we estimated that between 0 and 10% of existing traffic on Washington Avenue would divert to other roadways, and that would depend on which layout option was implemented. So the 4-lane option, which has the greatest capacity, would have little to no diversion, whereas we assume that the 3-lane option would have the highest or 10% diversion. Then our next step then was to analyze these options in synchro and also use some traffic. Our measures of effectiveness included, as Rick had also used, arterial level of service, corridor travel time, as well as simulation runs and sim traffic. So the table on the left there shows the results for the PM peak along Washington Avenue. And we found that the 3 options shown in blue all maintain the corridor level of service. And then in terms of travel time, we did see an increase that varied between the options from 1 minute to 2 minutes, but that would be over the length of the corridor. So realizing from the O&D analysis that a lot of vehicles weren't really were making shorter trips, a lot of motorists would see probably less than 1 minute in terms of their travel time increase, even with the highest option. What was also really important to stakeholders and to the neighborhood groups was understanding how this would affect parallel routes and streets through their neighborhoods. So we also conducted traffic counts along the major parallel routes, including Christian Street and Ellsworth, and then ran key intersections in synchro to see what the effects would be if all of that maximum diverted traffic went to those routes. And we found there was some increases in delay, but it was relatively minor, about 9 seconds at the worst intersection and only a couple seconds at the other intersections. So put all this together, based on these results, the city felt comfortable going to the public with all three options to get their input and use that to aid in the decision-making process. And so with that, I'm going to turn it back to Lily to talk a little bit about that process.
Thank you. So John's exactly right. We were looking at these three different roadway layout options and could see that we were weighing the benefits and the drawbacks of each, and we decided to actually turn that decision-making process and be a little bit more transparent and ask for input from folks that use the roadway more frequently. So we took all three options out to the community, and we planned a lot of public engagement for March through sort of early summer this year. And like Rick was mentioning with his project, we had to pivot all of our community engagement to be virtual. So we were able to actually meet with 22 local community organizations, reaching over 160 people through Zoom meetings as people started to adapt to this virtual reality. We also mailed postcards to near neighbors. So that was 5,400 postcards, letting them know about this process and a way for them to give their input. We put the word out on social media. So we had over 68,000 impressions on our own channels over a roughly 6-week period. And then we also got the word out through the press. So we ended up having 15 media mentions. We did interviews in both citywide newspapers, regional newspapers like the Inquirer, and also hyper-local news sources like Phil Latinos or South Philly Review. And then we actually recorded ourselves talking about the three different layout options and some of the different things that John went through in terms of travel time and diversion rates and the different benefits in terms of a safety improvements from pedestrian standpoint, as well as cyclist standpoint and driver standpoint. So we recorded those videos and we also translated them into Spanish, Vietnamese, and simplified Chinese because of the different language groups that are used in these neighborhoods. We ended up getting over 11,000 unique video views during the public process. We used an online platform to create a survey so people could also give us their input. And we had about 5,400 people take the time to give us their thoughts. And when we looked back and thought about what we were planning to do before COVID, hosting a couple of open houses, we actually found that we reached about 18 times more people through these methods than, and really just through the survey alone, not to mention all the other methods I talked about a minute ago. And the results were quite surprising, actually. We had an option for people in the survey to give a rating to each of the roadway layout options, as well as many other questions that we don't have time to go through. But we saw that 71% of people who gave us input on the survey rated the 3-lane option either 4 or 5 stars, so the highest rating. And you'll notice that these numbers here don't add up to 100% because they could rate each of the options independently. But it's pretty clear both from the citywide results as well as when we disaggregated the data by local zip codes that this was the clear preference. So based on that, we're moving forward with design for the 3-lane option, and we're reviewing block by block parking and loading regulations, developing pavement marking and signage plans. And it's really important for us to continue regular communications leading up to the paving project during construction and even afterwards to continue, I think, the understanding that the community has about the safety benefits of this project. Thanks very much.
Great, thank you. Thanks to all our presenters. It was excellent, and it actually gave us a lot of information in a very limited amount of time. We do have, I believe, like 5 minutes left for some questions and answers. And then we did receive some questions through the Q&A box here. And then there is one that I would like to ask. Probably this would be a good question for Rick and for John and Lily as well, just to give some feedback or a background information as to how these challenges are being met during the design process. The question is, as designers, we've seen challenges in getting a municipalities buying to the road diet concept. What methods and strategies can be used to get the locals to accept the road diet besides focusing on safety only?
Yeah, I'll start off. Obviously, in our case, we were able to make the safety comparison and show a great benefit to the 3-lane section. That being said, the analysis that we had done regarding travel times and making sure that the actual travel time increase was very negligible, along with the fact that intersection level service was not going to degrade, and queues were not expected to be an issue either. So there was that operational analysis component that helped us as well. And then when we were looking at alternatives, the 3-lane compared to the 5-lane, the cost of that was less as well. So that ended up, in our case, kind of worked out well.
I can speak quickly to Washington Avenue. I would say, with these projects, it really depends a lot on your context and the community you're in and what's important and what the needs are. So, for Washington Avenue, safety was obviously a huge part of it, but I think part of it also just comes down to being in an urban context. There's a lot of people walking and biking in the area, and just the ability for a reconfigured roadway to provide better for those modes. So to make it easier for people to cross the street, whether getting to businesses or getting to schools, to provide better amenities for transit riders. It is a transit route. And so this, I didn't have time to get into it, but this option would provide floating bus stops and better areas for them to light and, access transit vehicles, and then providing a better, bike facility and encouraging more people to feel safer biking along the corridor. All of those are important aspects. I'd say in other contexts, there's other things just that might be more comfortable for drivers. Not having to cross multiple lanes, leaving driveways and side streets can be easier in a 3-lane as opposed to a wider section. And not having that aggressive driving, it's a safety factor, but it's also can be a comfort factor for people too. So I don't know if Lily, you have any other thoughts?
Yeah, I'd like to add, I think from a community perspective and from a municipality perspective, it's really important to show how the roadway is functioning currently. And I think most roadway users can see that there are undesirable ways that these roadways are currently functioning, especially when you look at the left lane being, as other speakers have talked about, a de facto turn lane. You don't have a lot of capacity predictably going through that lane to begin with in the existing condition. And for our project, in fact, the right-hand lane was also in some ways not being used as a movement lane because it's often parked up by double parked vehicles. So I think by talking with local stakeholders, whether it's folks from a municipality or from the public, to really bring them into the decision-making process and talk about these pros and cons, as well as really pointing out what the existing condition is and what's not beneficial about the existing condition and how this road diet can actually solve some of those problems.
Great, thank you. I do have a couple of actually technical questions, I would say. One might be for Keith. Somebody asked actually if there is a recommended minimum distance between the offset intersections to reduce crashes in a two-way left turn lane situations. You remember the graphic that you showed in your presentation?
I was speaker. I'm just going to pull that up real quick just to make sure it's clear when I was talking about that. The offsets I'm showing here, if you can see it, it's not so much the distance between the offsets, but how they're arranged. So in the favorable part, if you're going, let's say, northbound, you have the left offset and then you have the right offset. You don't want a situation where you have them in opposite. So that's more or less what we're flagging. But you could argue as far as the distance for offsets, the short answer is no. We don't have any specific recommendations on what the distance is. That would be a function of speed and some other factors, but just wanted to clarify what we meant by the offset in the graph.
Okay. Another quick one for you. Are the context-based questions in design manual 2 programmed in any way? Because otherwise they can be just disregarded.
Yeah, I'm not sure exactly what that means. I'm not sure what program means. So I'm not sure how I can answer that one.
Okay.
If the attendee wants to contact us through the conference and sort of explain what you meant by that, I could.
Definitely, thank you. Another question for the city, for the Washington Avenue. Was a cycle track considered instead of 2 bicycle lanes? If that, how was the decision was made? And in that context, I guess maybe you might want to also elaborate a little bit about the top challenges that you guys faced, being kind of like familiar with the history of the project. I know you have a lot to say than the 50 minutes that you spent on it. Maybe you might want to use this occasion to.
I'm sorry, I need to interrupt quickly. I just want to let you know you have like 4 minutes left.
Thank you.
Okay, thanks. In terms of the cycle track, and it actually goes back to the challenges, I could speak to that. This corridor has a ton of driveways. There's just so many curb cuts and driveways. And so I think that was a challenge in laying out protected bike lanes, but it would be even more of a challenge for a 2-way cycle track on one side of the road because of kind of the layout and sight distance. But even more so, you have to keep in mind, this was a repaving project. It was trying to limit signal work. And so with a 2-way cycle track on one side of the road, it gets really complicated at intersections, and you kind of end up needing bike signals most likely at every intersection, which would kind of be outside of the scope of a limited scope repaving, because you'd probably be needing to redesign all the intersections. I'll let Lily.
Yeah, the second part of your question was sort of about the project history. Yeah, so this project has a bit of baggage, I'd say, from a community standpoint. And I think that what we heard in previous phases of this project, when we did different outreach, actually with different design ideas, was really some of the questions that, working with WSP, we were able to answer this go around. So a lot of the traffic modeling, updated traffic counts, as John mentioned, the work on the diversion. So really being able to look at what the effects would be in some of the neighborhood streets off of Washington, the highway traffic, whether that, whether Washington was really sort of a crosstown cut through, or if it was more functioning as a local street. All of those questions were legitimate questions that the community had before in project phases that we weren't able to answer. So we actually put this project a bit sort of on hold over the last couple of years so we could go and do our homework and make sure that we had those answers. And I think that it paid off because we were able to kind of have a very transparent and open conversation with stakeholders.
Great, thank you. We're almost running out of time here. It's 5:04. I would like to thank you all, our presenters and all the attendees for attending our session. I hope you benefited from it, and I wish you all a very nice evening. Bye now.
Thank you.
Thanks.
Thanks, everyone.